So let's continue talking about inverse trig functions. So in the last video, we saw that the sine function takes an angle theta and sends it to a real number y. And its inverse, sine inverse, takes this real number y and sends it to the angle theta. And well, what kind of theta values are these? Or in other words, what is the range of sine inverse? Well, we saw that the range is negative pi over 2 to pi over 2. Or visually, this would basically just be the right-hand side of the unit circle. So starting at angles negative pi over 2, all the way up to 0, all the way up to pi over 2. So these are the kind of angles we're going to get for the answers to these sine inverse problems. And we can do a similar thing for the cosine function. So cosine takes an angle theta and sends it to a real number. Let's call it x, because after all, cosine is the function that takes our angle and sends it to the x-coordinate of the point on that unit circle. And well, cosine inverse is going to have the opposite action. It takes x and sends it to theta. And well, we want to figure out what kind of theta values are we going to get? Or, in other words, what is the range of this function? And to find the range of cosine inverse, well, we have to think about the original function, cosine. So let's take a look at the function f of theta is equal to cosine theta. And basically, we want to find an interval for which this function is 1 to 1. So if we sketch a graph of this function, so here's my cosine function, right? It looks like this. It starts up at 0, 1. It's going to get its full cycle. So one full cycle will occur on the interval 0 to 2 pi. Right in the middle here we have pi. Right? And what we want to do is find an interval where this function passes the horizontal line test. Because where it passes the horizontal line test, well, on that interval, our function is 1 to 1. And if we think about it, if we look in this window here between 0 and pi, notice in this window, our function is 1 to 1. It passes the horizontal line test. So what interval? This is 0 to pi, or in degrees, this would be 0 degrees to 180 degrees. And so since our original function is 1 to 1 on this interval, that tells us that the range of the inverse is 0 to pi. Or if we were to visualize this, this is basically the top half of our unit circle. So starting at 0 and going all the way around to pi. Okay, so let's look at some examples. So example 1, let's evaluate cosine inverse of, how about negative root 3 over 2? So we need to find the angle whose cosine is equal to negative root 3 over 2. And the angles we have to choose from are, again, 0 to pi, the top half of the unit circle. So when do we get a cosine value or an x-coordinate of negative root 3 over 2? Well, that's going to occur at this angle here, right? This is when we get our x-coordinate of negative root 3 over 2. And so what angle is this? Oh, in radians, this is 5 pi over 6. So that's our answer. Cosine inverse of negative root 3 over 2 is the angle 5 pi over 6. Let's try another example. Let's evaluate cosine inverse, how about 0? So now we're looking for the angle whose cosine is equal to 0. Or in other words, when is the x-coordinate equal to 0? Oh, and that happens at the top of the unit circle. So here's my point, 0, 1. And what angle is this? Oh, this is the angle pi over 2. So that here would be my answer, pi over 2. Or if you like degrees, this would be the same as 90 degrees. Now, one more thing about these inverse trig functions, just some notation. We could write cosine inverse, and this is just the inverse of the cosine function. Or equivalently, we could also write it as arc cosine. So these two things mean the same thing, cosine inverse and arc cosine. Okay, so we've looked at sine, we've looked at arc or cosine, we've looked at the inverses of these. Now let's take a look at the other trig functions and their inverses. All right, so our other trig functions, let's just recall what their definitions are. So remember, tangent of theta, that's just the y-coordinate over the x-coordinate in the unit circle. Or if you like, let's see, y, that's the same as sine of theta. X is the same as cosine of theta. And so we get tangent is just equal to sine over cosine. The cotangent function, well, that's just the reciprocal of tangent. So x over y, or if you like, cosine of theta over sine of theta. Our cosecant function, remember that's 1 over, which one is it? 1 over y. So that's going to be 1 over sine of theta. And then secant of theta is 1 over x. So that's going to be 1 over cosine of theta. And well, what we would like to do is come up with their inverses. And in particular, we want to know what are the ranges. What kind of angles are we going to get out as our answers? And well, one way to do this is to graph them and figure out on what interval are they 1 to 1. But instead of going through all of that, we're going to see that they're very similar to the ranges for sine and cosine. So remember this guy here, the range of negative pi over 2 to pi over 2. Remember, this was the range for sine inverse, right? And if we were to just kind of visualize this, negative pi over 2 to positive pi over 2, that's just the right-hand side of our unit circle. And it turns out we're going to get this same range for not only sine inverse, but also tangent inverse, and also cosecant inverse. And if you remember this range, 0 to pi, so this is the top half of our unit circle, right? And this was the range for cosine inverse. And it turns out it's also the range for cotangent inverse and also secant inverse. And well, technically, the range for cotangent inverse is really the open interval 0 to pi. And that's just because cotangent is undefined at, well, both 0 and pi. So we have to consider the open interval. But basically, we're going to be still looking at these angles in the top half of the unit circle. And kind of a similar thing up here, technically, the range for tangent inverse, it's still negative pi over 2 to positive pi over 2, but it's an open interval. We don't include those endpoints. Okay. Now that we have all of our trig functions and also their inverses, notice we know the ranges for all of their inverses, let's look at some more examples. So what are we on? Example 3. Let's evaluate, how about tangent inverse of 1. Okay, so now we're looking for the angle whose tangent is equal to 1, right? So we're looking for an angle here. By the way, I could also phrase this same question as arc tangent of 1, right? Remember, these are the same thing, arc tangent and tangent inverse. Okay, so either way, what we're doing is we're looking for the angle theta. And let's see, what angles do we have to choose from? So remember, tangent inverse, that falls into this first category. And so we're looking for angles on the right-hand side of our unit circle. So between negative pi over 2 and pi over 2. And well, when does tangent equal 1? So basically we're looking for the angle whose tangent, so tangent of theta, should be equal to 1. And well, definition of tangent, again, that's sine of theta over cosine of theta, right? We got that from up here. So we want to know, when is this equal to 1? Well, sine over cosine, that's equal to 1 whenever sine of theta is equal to cosine of theta, right? I could just kind of start with this equation, divide both sides, multiply both sides by cosine. That would bring me to this equation. Or I could just notice that when is this fraction equal to 1? Well, that happens when the numerator and the denominator are equal. So we're looking for an angle where sine and cosine are equal to one another. And well, that's the same as saying that the y-coordinate should be equal to the x-coordinate if we look on our unit circle. Oh, and we know that that point is going to occur, here's our point, root 2 over 2 comma root 2 over 2, right? Notice x and y are the same. And well, what angle is this? This is the angle pi over 4. So there's our answer. This tells us that tangent inverse of 1 is equal to pi over 4. Or if you like, this is the same as saying arctangent of 1 is equal to pi over 4. All right, let's look at one more example. So example 4, let's evaluate about secant inverse of -2. Okay, so we're looking for the angle whose secant is equal to -2. And so remember for the secant function, so let's just remind ourselves of the range. So the range of secant inverse, oh yeah, that's this guy down here, 0 to pi. So that means we're looking at the top half of our unit circle. And well, when is secant, so secant of what angle is going to be equal to -2? Notice these equations here, they say the same exact thing. It's just one uses the inverse and one uses the regular function, but it displays the same information. And so to find this angle, well, let's think about what's the definition of secant. Again, secant is 1 over cosine. So what we have is 1 over cosine of theta equals -2. To solve this, I could multiply both sides by cosine of theta. When I do that, these guys reduce. We have 1 is equal to -2 cosine theta. And then we could divide both sides by -2. That gives us -1/2 is equal to cosine of theta. Okay, and so now we're just looking to basically solve this equation. When does cosine equal -1/2? Or in terms of an inverse function, we could write this as cosine inverse of -1/2 is equal to theta. Basically what we did here is, in a way, we kind of just took the inverse of both sides. We took cosine inverse of this side and cosine inverse of this side. And when we do that, cosine inverse and cosine, since they're inverses, they just cancel. And so what we end up with is this function here. Cosine inverse of -1/2 is equal to theta. Okay, so let's find this angle. And again, we're choosing angles from the top half. We're looking, when is cosine equal to -1/2? And that's going to be in the second quadrant, and that's going to be this angle here, right? This is when we get an x coordinate of -1/2. And that angle is 2 pi over 3. So there we go. Theta is equal to 2 pi over 3. And that is the answer to our original equation, which was secant inverse of -2. And we can see that's equal to 2 pi over 3. And there we go.